Hi guys, welcome to this set of videos. These videos are going to follow along with the notes that come out of your textbook from Chapter 8, Section 5. And what we've been doing in this chapter is we have been looking at rational expressions and rational functions. We just got done looking in the first two sections how we can simplify rational expressions by adding, subtracting, multiplying, dividing, factoring and simplifying those expressions. And then in the last two sections, Section 3 and Section 4, we looked at graphing rational functions and all of the things, all the interesting characteristics that you can find for those rational functions that help you kind of put together the pieces and show you what the graph of those functions look like. What we're going to do here in Chapter 8, Section 5 is we're going to begin to take a look at what's known as variation functions. All right, variation functions, you'll begin to see a lot of sort of similarities between these variation functions and rational functions, which is why they've been put together in this chapter. I also really like this section a lot because at the end we will see a direct correlation between this topic of variation functions in Algebra 2 and another science, in particular chemistry. So I can't wait to show you how that works. But before we jump into any of that, let's take a look at a couple of objectives or learning targets. These will kind of help you guys focus your learning as you make your way through this set of notes. These are the things that you'll need to be able to do by the time we get to the end of this set of videos and these notes. You want to be able to recognize and solve direct joint variation problems, and then be able to recognize and solve inverse, and there is even actually one more I didn't quite get in there. We'll call it combined variation, and the reason it's called combined is because it's a combination of direct and inverse. So we'll take that direct variation, that inverse variation, we'll put them together and get combined variation. So right now I only have three listed, direct, joint, and inverse, but if you take two of those, put them together, we'll get that fourth one, combined variation. So anyway, those are our objectives. Those are the things we're going to look at as we go through this set of notes. Let's go ahead and jump right into it by first showing you that these variation functions can be graphed, and in fact, they're just linear functions, all right? They're going to be linear functions, and I have an example for you right here, y equals 3x. This is a great example of actually direct variation. So let's go ahead and take a look at this one. What I've got for you is this guy, y equals 3x. Now, it doesn't matter at this point. We'll go over in a second what is direct variation and how you would recognize and stuff like that. So we'll just hold off on this for now and just kind of accept the fact I'm telling you that this is a direct variation. This one is a direct variation. Again, we'll go over that actually on the next page of the notes. We start with direct variation. But this is direct variation, and please notice, hopefully you can kind of recognize, you certainly will when I write it here, that it is in the form y equals mx plus b, where 3 is my slope, and if you were to just tack on that 0 back there, right? Adding 3x plus 0 is just 3x. Adding 0 doesn't change anything, but it quickly lets you recognize that your b, your y-intercept, is 0. So this direct variation function is in slope-intercept form. It's a linear function. So let's go ahead and graph this function. Now what we notice here real quick is that my slope, of course, is 3, and I go through a y-intercept of 0. So my y-intercept is 0. That means I go through the origin, and all of these variation functions will go through the origin. They'll all have a y-intercept of 0. My slope is 3. That means I go up 3 and over 1. 1, 2, 3 to there. I could also go down 3, right? And back 1, because that would be a negative 3 over a negative 1. If I go to the left one, and negative 3 divided by negative 1 still gets you a positive 3. So it's the exact same thing as going down 3 and back 1. And those work so well, we'll try a couple more of them. To there, to there, to there, and to there. There, I've plotted all of the points that'll fit on the coordinate plane that I've given you here, which is just 10 by 10. We go ahead and connect those dots with a smooth curve that extends all the way through the coordinate plane I've given you. put arrows on both ends so that I know you know that graph just keeps going to infinity, positive and negative infinity. And there we go, we have a graph of this direct variation function, y equals 3x. What I want to talk about here just for a moment is this idea right here. In this function, m is equal to 3, right? Where that is what we call the slope. Right? So the slope of the line is 3, m equals 3, right? Slope is represented by an m. Well, in this section here in chapter 8, section 5, we're not going to call it slope anymore. We're actually going to call it the constant of variation. We'll call it the constant of variation, and instead of giving it the symbol m, which is for slope, we're going to give it the symbol k. Now, it doesn't change anything, right? We're calling the slope by a different name. It still represents the slope of the function if you graph it, but instead of calling it slope, we're going to call it the constant of variation. We'll give it the symbol k, and in all of these problems, it just represents the slope. And in this function, that constant of variation right there, that k value, is 3. All right, so when we're going through these and I say the constant of variation, I'm talking about this guy right here, and it's just the slope of that variation function if you were to graph it. And that's essentially the long and short of everything I kind of described for you right here. All these guys are going to be linear functions. They'll all be in the form y equals mx plus b. B is 0. They'll always pass through the origin, all of them. Direct, inverse, joint, combined. They'll all go through the origin. And instead of letting the slope, calling it m, we'll just simply call it k, which I told you right here is the constant of variation. So what we'll do is head on over to the next page of the notes. We'll take a look at that first type of variation, which was direct variation. We'll talk more about how you'd recognize it and go about looking at some problems. So head on over to the next page of the notes, and I'll meet you guys there.